Hello everybody, Mr. Ferrante here, and here's the video to go over the entire mock final and give you more of a chance to practice. So we're going to check answers so you know which problems you got right, which things you need more practice on. I'm going to do the problems myself and explain in more detail each of those problems. And finally, as we learn, we're going to go ahead and give you a chance to practice more or do further learning on YouTube. So first, let's check answers. You can pause the video at any time. So here are just quick answer checks. So number 1, 2 through 8 is right there. Pause the video as needed. Then here's the rest of them. 9, 10, 11, 12, 13, 14. And there's number 15. So pause the video, double check your answers, and let's now do each of these problems in particular and then show you how to practice more on your own. So I'm going to go ahead and split my screen here. View split screen. And down below, I'll show you in a bit here, I'm going to basically have a reference for what to search in YouTube to get more practice. So if I scroll down to my document, I'll explain this in a second. All right, let's start by doing the first problem. Now for these kinds of problems, the first thing you need to do is just know the different expressions and translations of the individual words. So in this case, um, there's 2 by itself translates to the number 2. Okay, less than, in this case means something minus. If you were thinking that's this less than, this is for something is less than. So is less than is an inequality. But if you just say less than by itself, it means subtract. For example, if someone makes $30 per hour and their coworker makes $5 less than them, that would be $25. Right? So in everyday English, the word less than means to subtract. And that's what it is here. So let me erase my writings here and let's continue translating the individual pieces of the sentence. So 2 is the number 2. Less than already means subtract. And so already I can start writing an expression. If it's 2 less than something, it's already something minus 2. That is 2 less than something. What is 2 less than is this. Here, I'll put it in blue. 2 less than the product of x and y. So again, each word in here translates. Product means multiply, and in this case, it's x and y that you're multiplying together. So we have 2 less than the product of x times y. I'll write it as xy. And then the word is, I'll put this in green, is translates in this case to equals. So all this stuff is equals the quotient of x and y. So quotient means the answer to a division problem. And the two things you're dividing in this case are y and 5 in the same order. So is equals the quotient division of two things, in this case, y and 5. So that's the translation of this sentence. And you really have to break down each word into like what symbol. Now to practice this more, if I scroll down my document, it's by split screens. You can see here, to practice more, type in either of these two search phrases into YouTube to get tons more problems. And here's an example. So I'm going to type in this search phrase into YouTube. And then what you're going to get is a lot more videos that you can either learn from or practice. So here's a great example. I'm going to click on the first video here. So if you feel like you want to practice to learn more, then you can just watch the video outright and don't worry about trying the problems yourself. So, all right, so if you just want to practice but not learn, like watch the teacher, here's what to do. Do the problem yourself, so pause the video, try the problem yourself, and then play the video. That way you'll get a comparison of like what you thought versus what the teacher thought. So, and then you can skip ahead in the video to the next problem once you've done this one. So here's another one, right? 6 less than 5 times the number is 9. What's the number? You would translate this yourself, pause the video, translate it yourself, and then just play the video or skip forward to see if your translation was correct. That way you can practice a ton of problems on YouTube, and if you mess something up, the video will explain each step for you so you can see where you went wrong. This is a great technique that works all the time for pretty much every topic in our class. So I encourage you to use this as much as possible to learn algebra. All right, number two, evaluate this expression when x is 7 and y is 2. So these kinds of problems come down to just substitute numbers for x and y and follow the order of operations. So as a reminder, we're going to need to follow PEMDAS, the order of operations. So PEMDAS stands for parentheses, exponents, multiplication and division, and then addition and subtraction. So let's first substitute 7 for x and 2 for y. We've got 3 times. Whenever I substitute, I use parentheses. So x is 7, so I'm going to put that in parentheses, minus the y value is 2, and it's that whole thing squared, plus x is 7 and y is 2. So I'm done substituting 7 for x and y for 2, or 2 for y. And next step is to follow PEMDAS. So first, are there any parentheses we have to handle first? Yes, there are. Before we can do exponents, like this one here, the power of 2, before we can multiply, we need to take care of the parentheses. So inside this big parenthesis, there's a 7 minus 2. So 7 minus 2 needs to be done before multiplying the 3 and before doing the power of 2, because that's an exponent. And for now, I'm just going to keep these the same. That's 7 times 2. All right, 7 minus 2 is 5, so we've got 3 times 5 squared. 7 times 2 there. All right, now that we're done handling the information inside parentheses, now we can move on to exponents. And this is the first place I see students have a question. They're like, well, should I multiply by the 3 or should I do the power first? The answer is right here. You have to do exponents first before multiplying. So let's do the exponent first. That's squaring. 5 squared means 5 times 5, and 5 times 5 is 25. And then finally, these all stay the same. And now we're down to, let's multiply everything that has to be multiplied. 3 times 25 is 75. And then 7 times 2 is 14. And then finally, there's no division, but there is addition, so we can move on to addition. 75 and 14 is 89. So that is our final answer. And to practice more, go ahead to YouTube and just type in either of these two search phrases. And then when you see a problem, pause that video, try the problem yourself, and then resume the video and see if you're correct. All right, next up, number 3. So solving for x, this would be the usual steps where it'd be wise. Okay, first of all, let's do this. Let's do this. Let's make a mistake on purpose. If a student says, hey, we should subtract 6 first, that seems, at first, that seems completely reasonable, but in reality, this actually isn't 6. It's 2 times all this stuff. It's 12, because it's twice x plus 6. So this plus 6 is deceptive. It's not really 6. It's actually 12. So the first step you need to do when you're solving for x is make sure you distribute any parentheses. So distribute to any parentheses. In our case, 2 times x is 2x, 2 times 6 is 12, still minus 9, and still equals x minus 1. I'm going to draw a line separating the two sides of the equation. Once you've distributed, you can combine terms. 12 minus 9 is 3, and it's still 2x plus that 3, and then x minus 1. And now our goal is to get x on the same side and to get x to be alone. So you could either subtract 2x to both sides. That would be a legal step. If you do this, you're going to get negative 1x here minus 1. I'm going to choose a different step. This step works. It'll work. If you want to try it, go for it. I'm going to back up though. I'm going to choose a different step. I'm going to choose to subtract 1x from both sides. And the reason I'm choosing this is because 2x minus x is just 1x. That's going to be easier at the end because there's no negative with it. So that's my choice. All right, final step, subtract 3 to both sides. Those cancel out, and I've got x equals -4. Done. So to practice more problems in YouTube, type in either of these search phrases, and there's going to be tons of problems. So for example here, if I type in solve for x multiple steps in YouTube, you're going to get a whole bunch of practice problems just like this. And so that was fractions. I would skip that for now. We'll do it later. But there's a problem. This one's almost exactly like ours right here. So here's a great one. If we play this video, I'm sure there'll be, yeah, there's ads. So once the ad gets through here, so let's scroll ahead to the first problem. Perfect. All right, so you would pause the video, try this yourself, and then resume the video or fast forward it until you can see if you were correct. But it's a great way to check your answer, and if you mess up anywhere, you can see in the video which step you made the error on. So it's a good way to practice. All right, moving on. Okay, number 4. So number 4, you can solve two ways. You can solve with a regular solving for x, or you can use fraction busters. And I'm going to do it both ways. So fraction busters. So here's both ways to solve this. All right, with regular equation solving, you just do your regular steps. There's nothing different to do. So first, we could subtract 3. Like usually you save all the x stuff for the end, right? Like over here, we didn't deal with dividing or multiplying until the very end. In fact, at the very end, we didn't even need to multiply or divide. If this had been 2x equals -4, we would divide by -2, but that wasn't necessary for that problem. But you usually save all the dividing for the end. So that's what we're going to do here. Subtract 3 first. Those cancel. Then we've got -x/2. 1 minus 3 is -2. And now we need to get rid of this negative, like a half in front of x. So I'm going to do it in just one step and multiply by -2 to both sides. That's because this -2 and that -2, one's in the numerator, one's in the denominator. They cancel out, leaving just x by itself. On the right-hand side, -2 times -2 is +4, and we're done. So that's just regular solving, no fraction busters. Okay, fraction busters is the technique of eliminating fractions as your first step. And so in this case, the only fraction is a half, so you want a number that 2 will go into. So you can multiply both sides by 4, by 6, by 2. Any of those choices would work. I'm going to choose to multiply this equation all by 2. So 2 times this guy, 2 times that guy, and then 2 times that guy. So I multiplied everything by 2, but you could also multiply by 4 or by 6. Any number that 2 goes into will work. So for me, I chose 2. All right, 2 times 3 is 6. Here, the 2's cancel out. That was the whole point. So it's just minus x is left over. 1 times 2 is 2. Final steps, subtract 6 first. Those cancel out. You have -x equals 2 minus 6 is -4. And then here, we still need to get x alone. It's not alone yet. So -x is the same as saying -1x. So I will divide -1 to both sides to cancel out that -1. And you have left over x equals a negative divided by negative is positive. In this case, +4. So you got the same answer either way. To practice more fraction busters, then go ahead and search YouTube for any of these key phrases, and you're going to get tons of videos to pause the video, try those problems yourself, and then resume the video to see if you are correct. All right, number 5 and then 6. Number 5 is definitely intended for fraction busters. So for number 5, we're going to use fraction busters. What number can 9 and 3 both divide into? So 9 goes into something, and so does 3. 27, that would totally work because 9 goes into 27, and so does 3. So that was a possibility. There's a smaller possibility, so even 9 would work because 9 goes into itself, and so does 3. So the easiest possibility is 9, but if you chose 27 or a bigger number that 9 and 3 go into, it would still work. But I'm going to choose 9 because it gives you the easiest numbers to deal with. All right, so multiplying everything by 9, 9 times everywhere. This is 9 over 1. The 9's cancel out, leaving 2x. 3 goes into 9 3 times. 3 times 1 is 3. Remember, it's still a minus, so minus 3, because it was a minus before, so it's still minus. And 2 times 9 is 18. All right, final steps. Let's add and subtract before dividing. So plus 3 to both sides would be the easiest first step. Those cancel out. 2x equals 21. Divide both sides by 2, and x equals 21 halves, and you can just leave it as 21 halves because it doesn't reduce any farther. All right, that is correct. The answer in this case is a fraction. And to try more problems with fraction busters, go ahead and search YouTube for any of these expressions, and you'll get more problems just like this one to practice. All right, number 6. This is still fraction busters, but in this case, you want to clear decimals. So either you'll multiply by 10, by 100, by 1,000. It just depends how many times do you want to move the decimal. If you multiply by 10, the decimal will move 1 time. Multiplying by 100, the decimal will move 2 times. And by 1,000, the decimal moves 1, 2, 3 times. In our case, we only have 1 decimal place everywhere, so we need to move our decimal place by 1 place, and therefore 10 would be the easiest thing to multiply. So times 10 to each term, 10 times this, times 10, and that will move the decimal by 1 spot, in this case giving us 4x, minus 0.8, the decimal moves by 1 spot, giving us 8, and 1.2, the decimal moves by 1 spot, giving us 12. So after one step of fraction busters, in this case, times 10, the decimals are cleared. All right, on to regular solving. Add and subtract before multiplying and dividing. So plus 8, we have 4x left over on that side, and 12 and 8 is 20. Last step, divide by 4 to get x alone, and now x equals 5. Done. So to practice more, go to YouTube, type in either search phrase here, play the video, but pause it so you can try the problems yourself, and then continue the video after you did it yourself to see if you are correct. All right, number 7 and 8. Number 7, solve the inequality. So first, solving these is just like solving a regular equation with an equal sign. Nothing's different except for one thing. At the end, if you end up with a like negative 2x is less than, say, let's say 8, if you divide a negative to an inequality, then that's the time to remember you must reverse the inequality. And same thing if you multiply a negative to both sides of inequality, you also reverse the sign. Otherwise, the sign stays the same side or same direction, and you just solve as if it was a regular equation. All right, let me clear this out and then do this problem. All right, let's make a mistake at the very beginning. Same as before. If you're thinking minus 1 to both sides, that's a good idea, but this is not really 1. It's actually 3 times all this stuff. So it's really negative 3. So subtracting 1 isn't really the truth. This 1 is actually a negative 3 because it's negative 3 times all this stuff. So really, our first step has to be to distribute. So let's distribute the parentheses. So negative 3 times 2 is negative 6x. Negative 3 times 1 is minus 3, and still greater than 7. All right, now that we distributed, we can do regular solving for x. Let's combine like terms. 4x minus 6x is negative 2x, still minus 3, and still greater than 7. Before dividing, it's easier to add and subtract to both sides. So in that case, we'll add 3 to cancel out the negative 3. We're left with negative 2x is greater than 7 plus 3 is 10. And finally, divide by negative 2. And since we're dividing by a negative, we're going to reverse the symbol. So we've got x is less than negative 5. If I were to graph this, it didn't say graph it, but we're going to anyway. Here's a number line. Here's 0. Here's 5. Here's negative 5. Since it says x is less than negative 5, there's an open circle at negative 5 because you can't equal negative 5. It doesn't say this or equal to. It just says less than only. So open circle for less than, and then which direction is smaller than or less than negative 5? That is to the left, because negative 6, negative 7, and so on. So you would shade to the left-hand side. If you want to practice more of these, go ahead and type in these search terms into YouTube, pause whatever problem the person's doing, try it yourself, and then resume the video to see if you are correct. Okay, number 8. This is called a compound inequality because it's kind of two equations in one. It's this equation saying that negative 2 is less than 2x plus 2, and at the same time, it is also, I'll switch to blue, it is this equation saying that at the same time, 2x plus 2 must be less than 8. So it's really two equations in one, and you can solve it either all in one shot or as separate equations. I'm going to solve it as two separate equations, and then at the end I'll go back and solve it as one equation. So here's the separated versions. All right, knowing that this is two equations, then let's solve them separately, and at the end combine them. On the left-hand side, we'll subtract 2 to both sides. That leaves us with 2x on the right side. Negative 2 minus 2 is negative 4. Divide by 2. Because we're dividing by a positive, the inequality stays the same direction. We're not dividing by a negative, right? This isn't negative 2 we're dividing by, it's positive 2. So the symbol stays the same. Negative 4 divided by 2 is negative 2. So there's one side. And at the same time, not only does x have to be larger than negative 2, but once we solve this, we'll see the other side of x. Those cancel out. 2x is less than 6. Divide by 2. And then on this side, x has to be less than 3. So the solution is this. X has to be less than 3 and at the same time also larger than negative 2. That's how you'll see it written. It means both at the same time. On a number line, it looks like this. Here's 0, 1, 2, 3, negative 1, negative 2, negative 3. There's an open circle at 3 because x is less than 3. There's an open circle at negative 2, and x has to be less than 3 but also larger than negative 2. So you only shade the part between these two. So x can be any number between, but it can't go beyond this range. So that's the way to split up the equation into two, and here's the way to do this as one shot. Just delete stuff at one time. All right, here's a repeat. When solving this kind of equation, you can treat it as like a three-part equation. Subtract 2 from all three sides, left, middle, right. Those cancel out. So 2x is less than 6 on this side. Negative 2 minus 2 is negative 4. Finally, divide by 2. Those cancel out. And then you've got x is less than 3 on one side, but also larger than negative 2 here. And that gave us the same thing we had here, and the graph would be the same as well. So to practice more, you want to search up solving compound inequalities on YouTube, and you'll have more practice problems. All right, number 9. Is x equals negative 4 a solution to this inequality? All we need to do is substitute negative 4 in place of x and find out is it a true statement or false. Because if negative 4 is a solution, when you plug it in, it should make a true statement. So let's find out. 18 minus 2 times negative 4. Is it true that that is less than 26? I don't know. Let's just keep calculating. All right. Negative 2 times negative 4 is positive 8. Is that less than 26? Oh, sorry, that's, like I said, positive 8. 18 plus 8 is 26. Is it true or false that 26 is less than itself? And that is false. 26 is not less than itself, so this is false. And therefore, the three dots is the math symbol for the word therefore. Therefore, x equals -4 is not a solution because it doesn't make the equation true. Solutions are values that make the equation true. All right, to practice more problems, search up this in YouTube and you'll get more problems to practice and go from there. Number 10, this is known as function notation. So this one, a bunch of you really should just watch some videos on function notation first and then come back to this video. All right, so here's my brief introduction. So in function notation, it's a machine where you input values and get outputs. In this case, let's say I wanted to find out, so f is the name of the function, it's function f, and x is the input. So if I input, let's say, I don't know, 3 into function f, I would have 6 minus 5 times 3. So this part represents the input, and this is the equation name. That's the name of the function. And this entire thing gives you the output. It stands for the output. So in this case, if I input 3, then the answer or output is 6 minus, let's do it up here, 6 minus 15. That is negative 9. So if I input -3, I get an output of -9. And you would read this as f of 3 is -9, and it means if you input 3 to the equation f, you get -9 as the answer. And so this whole thing, f of 3, that's the answer of -9 when you plug in 3. All right, on to our actual problem. So for our problem, they were asking us to plug in 0, and so that's what we'll do. Erase my stuff. All right, find f of 0. So let's input 0 into equation f. So 6 minus 5 times 0. That cancels out. That's just 0. And we get f of 0 is 6. So when we input 0, we get 6 as an answer, and therefore f of 0 is 6. The answer is 6 when you input 0. For more problems, definitely go practice function notation here. And because some problems are backwards. In fact, let's do one now, honestly. Here's a backwards problem. Um, okay, if f of x equals, let's say, 10, find x. So this is a backwards problem. They're telling you if you get 10 as an answer to the output, what was the input that matched it? And so to solve this kind of problem, you would do this backwards and basically put 10 on this side, right? 10's the answer. And the question is, what's the x value that gives you 10? So you would solve this equation we have here before us, solve this for x to find out what x gives you that. So in our case, we'd subtract 6 to both sides. 10 minus 6 is 4. Negative 5x. Let me write this over here. Divide by -5. And so the answer is x equals -4/5. I made it up so we got fractions, but basically there's two directions. Either you input something for x, or they give you the answer and you have to find x. And I think that if you search the videos, you're going to find both of those kinds of questions. So right here. So yeah, check out function notation on YouTube and find lots of practice problems until you're 100% confident in those questions. All right, number 11, is the graph at the right a function? So here's what to know. For functions, the rule is each input, which is x, has to have only one output, or y. So in this graph, does each x value have only one y? Here, let's look at like x equals 10. For x equals 10, right, the graph lives up here, and the graph exists down here. So for an x of 10, y could either be this height or this height. That's two different y values for one x value. So already this is not a function, not a function. And it's because some x values have more than one y value. A different way to do this is to use the vertical line test. So vertical line test, if you pass a vertical line through the equation or through the graph, if it touches at more than one spot vertically, that means it's not a function because it means that for a certain x, y has two possibilities or maybe more. Like this graph right here, that would have three possible y values for one x value, and that's definitely not a function. And for the graph we were given, it doesn't pass the vertical line test because even though it passes right here, right, that would just be one x value, but it doesn't pass all these lines and therefore not a function. If this had been sideways, by the way, or that way, so if this graph had been this, a parabola is the name of the shape. If this parabola had been opened vertically, then the vertical line test would pass because at each time that you draw a vertical line, it only crosses once on the graph. So this would be a function. All right, let's do number 12. Let me erase my drawings. Okay, domain and range. So as a review, domain is the set of possible x values that the graph covers, and the range is the possible y values that the graph covers. So in this case, what x values does the graph cover, right? It goes from an x of 5 right here, and then it goes over to the right forever, really. I'm assuming there's arrows on here. They didn't draw them, but I think it was meant to put that way. So in this case, x goes from 5 over to the right forever. So the domain is x is greater than or equal to 5 because the graph covers x values from 5 over to the right forever. Okay, for y values, what's the highest and lowest this graph ever goes, right? I can see that a y of 0 is right here. That's a y of 0. Y equals 1 is this height, and the graph exists for that height too. Height of 2s are here. The graph also exists for height of 2. So y, it goes from 0 up forever, and it goes from 0 going down forever. So this graph eventually covers all values up, it covers 0, and it covers all values going down. So y, the range, is all real numbers. All real numbers. And if you want, you can put y is an element of the set of real numbers. This is math notation. A double-stemmed r is the symbol for real numbers, which are decimals, fractions, and just all the numbers that are possible. And this little other symbol means element of. So y is everything. All right, for more practice, go ahead and search up these search terms in YouTube, and you'll get more practice problems. Almost there. Number 13, write an equation of a line in slope-intercept form. So that's the first thing. Here's what slope-intercept form is. It's the classic y equals mx plus b because you're given a slope and an intercept. And that's why it's called slope-intercept form. So to do this problem, we need to know two things, the slope and intercept. So let's find the slope by taking our 2 points and finding the rise over run using this equation. y2 minus y1, that'll find the rise between the heights, and then x2 minus x1 will find the run. So let's label these. That's x1, y1. It's our first xy point, and the other one will be our x2 and y2. In other words, point 2x and point 2 is y. All right, so second y coordinate minus the first one, that would be 4 minus 2 divided by the x values will be 0 minus negative 1. Make sure you catch that it's 0 minus a negative 1. 4 minus 2 is 2. 0 minus negative 1 is positive 1 because negative negative is positive. And then 2 over 1 is the same as 2. So at the end, we've got this. We know y equals a slope of 2 times x plus some y-intercept. I'm not quite sure yet. All right, to find the y-intercept, there are two ways here you could do. 1, if you can see already, they're giving us the y-intercept. 0, comma 4 is the y-intercept, so instantly we know that this is 4 because 0, comma anything is a y-intercept, so we're done. Let's just say for the sake of argument, so this is the final answer by the way, but let's say that it wasn't 0, 4 and it was, I'll make something up. Let's say the answer, or it gave us like 2, comma 6. So what line would go through, let's say it had the same slope of 2, but it had 2, comma 6 instead, and not 0, 4. In that case, here's what you would do. Here, you would just have to put plus b, pretending like we don't know what b is, and you could then plug in the 2 and 6 for x and y to find out what b is. So x would be 2, so 2 times 2, y would be 6, and then you would solve this for b. So 2 times 2 is 4. You would subtract 4 from both sides. Let me give myself some more space here. Subtract 4, subtract 4. That's 2. So then you have b equals 2. And the equation in this case would be y equals a slope of 2x plus 2. So if you don't know the b, because they don't give it to you, you can still plug in one of the points for x and y and solve for the b. That wasn't needed here. All right, for more practice, of course, you can type in this search phrase into YouTube and you'll get a ton more practice problems. All right, let's do number 14. So 14, find the equation of a line in slope-intercept form. That's still mx plus b. That is parallel to this line. So parallel means same slope, but different y-intercept. Different y-intercept. So we know the slope of our new line definitely has to be 2. So far we know this. Our new line to be parallel has to be y equals 2x to be same slope, but then plus a different y-intercept. And we want our line to go through 0, 0. But that's already the y-intercept because 0, comma something, right, 0, comma whatever, is a y-intercept. So in our case, they're giving us the y-intercept of 0, so we have y equals 2x plus a y-intercept of 0. That doesn't really matter, so you have like y equals 2x is the solution. Done. But same thing. Let's say this point was not 0, 0, and they're like, hey, find a line parallel to this that includes the point, I don't know, 8, comma 6. Okay, in that case, what you would do is you would start here and you would plug in 8, comma 6 and find b. So I'll do that in a second here. So if you're not given the y-intercept just outright as we were, then you can always find b by plugging in our case. Let's plug in 8 for x and 6 for y. So 6 is y, 2 times 8 for x, plus some intercept. We're going to find out what it is. 2 times 18, or 2 times 8 is 16. Subtract 16 to both sides. And now you can see that 6 minus 16 is negative 10. So our y-intercept b is negative 10. And therefore, the equation that would be parallel to this one, but goes through 8, comma 6, would be y equals same slope of 2, but different y-intercept of negative 10. So that would be the answer if they said it goes through 8, comma 6. And again, to find more practice problems, type this into YouTube, find a video, and then pause the video, try those problems yourself, then resume the video and see how close you got to the answer. All right, final question. So there are two ways to do this. You can use either technique of the substitution method or elimination. I will do both because sometimes one's easier than another, but you need to know both. So let's say substitution method on this side and then elimination method on this side. Okay, let me write down the equations over again. So for substitution, let's just start with the original problem. 2x minus 3y is 7, and then x plus y is 6. Same thing over here. I just need to rewrite the problems. All right, so for substitution method, you need to get one variable alone. So you need to get either x equals or you need to get y equals by itself. Once you have that, you substitute into the other equation. So for us, it looks easiest to solve the second equation for x or y because there's no dividing, it's just regular x and y. So I'm going to choose to solve, let's call this equation 1, call that equation 2. I'm going to solve this for x by subtracting y to both sides. And then we get x equals just 6 minus y. So this is our new equation. And now for the substitution technique itself, since x equals or is the same as 6 minus y, we can substitute this in place of x in the other equation. So that is the substitution method. So equation 1, after substituting, becomes 2 times, but instead of x, it's going to be 6 minus y, but still minus 3y equals 7. So basically, I just rewrote this first equation over again, except for in place of x, I substituted 6 minus y in place of the x, and that is substitution. All right, now just solve regular. Distribute to the parentheses, 2 times 6 is 12, 2 times negative y is negative 2y, still minus 3y, still equals 7. Combine terms, negative 2y minus 3y is negative 5y, and it's still 12 minus that equals 7. I'll continue over here. So I have 12 minus 5y equals 7. Subtract 12 from both sides. We got negative 5y equals 7 minus 5, or 7 minus 12 is negative 5. Divide by negative 5 to both sides, and we end up with y equals 1. Okay, once you find out one variable, in this case y is 1, then just plug that back into either equation to find the other one. So I'll use this equation because it looks the easiest to plug into. So we've got x plus 1 for y equals 6, and then subtract 1 to both sides. X equals 6 minus 1 is 5. So now I found both x is 5 and y is 1. So this is the point where the two lines intersect each other, and that is the solution to the system. Here's the same thing, but using the elimination method. With the elimination method, you basically want to add the equations vertically to force either x's to cancel out or y's to cancel out. But in this case, nothing cancels because 2x plus x, if you add them vertically, that gives you 3x. If you add negative 3y plus y, that gives you minus 2y, and nothing cancels. So in this case, you would have to multiply one of these equations by something to force either x or y to cancel. So if you want to cancel the x's, you can multiply this whole equation by negative 2 to force a negative 2x here that would cancel. Another choice, you could also multiply by positive 3 to force the y's to cancel if you want a 3 there. But I'm going to choose the x's. So after multiplying the second equation by negative 2, we get this equation. So top equation stays the same, minus 3y still equals 7. The bottom equation, negative 2 times x is negative 2x. Negative 2 times positive y is negative 2y. And negative 2 times 6 is negative 12. So now if you add the equations vertically, the x's cancel out. Negative 3 minus 2y is negative 5y's. 7 minus 12 is negative 5. And we get the same thing as we had before. So y equals 1. Plug that back into either equation and you're going to get an x of 5. And you get the same solution as before. So that's the elimination method. That's it. So to practice more on YouTube, just search up the key terms you can see below for either elimination method or substitution, and you get tons more practice problems. Just pause those videos, try them yourself, and you've got infinite practice there. All right, that's it for me. Have a great day. I wish you the best of luck on finals. See you next time.